you. And I don't wanna say, but the second that I wait, no, the words can't get to you. We push and we pull, it's wrong and it's right, it's not black and white. But I know that we'll always be something golden. It's only worth taking to make it. If you took a little time to open up, to see my love, to see my love. It's only worth taking to make it. If you took a little time to open up, to see my love, to see my I don't wanna care, it's a little unfair that you'll never not care for me. I was always scared, no, I couldn't be prepared for you just to be a memory. We push and we pull, it's wrong and it's right, it's not black and white. But I know that we'll always be something golden. It's only worth taking to make it. If you took a little time to open up, to see my love, to see my love. It's only worth taking to make it. If you took a little time to open up, to see my love, to see my
Good evening, everybody. Can you hear me? Can you hear me? Can you hear me clearly? Am I too loud? Am I too soft? Am I too juvenile? Am I too annoying? Don't answer those questions. Where's that face button? There we go. Hey! Greetings, I am a lot of things. Thanks, Russ. I can always rely on you to keep it real. Man, it has been a long day today. Like, a long day. Oh, hang on. Why is this song on repeat? Pretty sure this is exactly what we just played. Let's do this. There we go. Sorry about that. Is it cold in my house? Relatively speaking, no. But I do feel the cold a little more than the average Joe, and so I like to have warmth around me. Plus, I have tea, so I may am getting too hot and removing this jumper. But yep, I live in Queensland and I have a very thick woolly jumper on, so sue me. Sorry about that. So anyway, good evening to everybody. Who we got? We have Serializing Archbishop Atwolf, Sysop. And there's some, I can't read some of the backgrounds. Ilya Pavkin. The blue contrast on my background, I struggle to read. Dr. Show or DR Show. Good evening to all of you, or good morning, or good afternoon, wherever you may be. I hope you are well. Hey, Zorkat's here as well. It's we're in a good spot actually up here in the Sunshine Coast. We have no longer got any active coronavirus cases on the coast, which is awesome. There you go, see? Aaron's a Queenslander, and he also has a jumper on, so take that. So yeah, good job, Sunshine Coast. We have no COVID cases. Hey, so good. I'm very excited about that. Sorry, I said Sunshine Coast, didn't I? Yeah, we still have them in Queensland, but not up here. The last one we had was on the 4th of May, and that person is now apparently officially completely recovered, which is great. Hello, Civilized. Thanks for joining in again. It's nice to see you. But yeah, today was a rough day for those people who've been following along on the twits, bashing my head against building the Kiwi extension, which is this Mimikat source code using the MinGW32 compiler on Linux. And that was awful. Yeah, that would have been a bit rough if I said that was dead. That would have solved the problem very quickly. But yeah, I actually went and submitted a bug report to MinGW compiler project because I genuinely think there's a bug in the compiler that I'm using, and it turns out that MinGW32 on Linux is not a MinGW product. So they are illegitimately using the MinGW trademark on that platform. I didn't know that. You lives and learns, don't you, hey? Anyway, I won't get into that because I'll end up turning from tea to some kind of alcoholic beverage. But if you want to chat to me about that, I'm happy to do that maybe off stream. Okay, so hacking without tea is very uncivilized, so make sure that you have your tea. I have another dong ding. I had quite a bit of gyokuro earlier today, and I've had a couple of coffees and a couple of blacks, so I felt this would be a nice thing to wash the old dinner down with. So what have you guys got? And I'm also avoiding the hot chocolate, the dark chocolate again, because I'm trying to be a good boy. But I think next stream we'll probably end up getting some chocky out. Rooibos, that's a very good choice, caffeine free. I haven't had rooibos for a little while, but it is a very good brew. Hacking with pork, Irish breakfast, absolute classic in the black tea range. Is that a T2 Irish breakfast? I find the T2 one has a little bit more strength than say the other sort of mainstream brands, which is nice. Yeah, I love a good Irish, hey, really nice. Pork tea. That's pretty funny. All right, so I hope you've all got your beverages, whatever they may be. I am now going to go and hang out in the corner with my friend Nelson, who is pointing his finger at me, which I felt was fitting. So hang on, let's go this way. Maybe I should rotate the camera around so this comes from that side. But yeah, yes, indeed. I felt after last week's stream I should have something like this going on because, it kind of sums up the experience that I had. 4 hours of utter pain, which I thought was going to be considerably easier than it was. Anyway, I have a solution, or I believe I have a solution. And so that's the first thing that we're going to implement today. We're going to get the solution of this channeling shenanigans out of the way. For those of you who weren't following along last time, the problem that we had is that we weren't able to read kind of line by line and support the notion of new lines using the standard in, standard out hooks that were in place. Also, the problem that we had too is that this kind of assumes that standard in and standard out are always going to be text, which isn't necessarily going to be true. Now, in the context of Meterpreter, it's probably always going to be true, but I'd still prefer to not be tied to strings if we can avoid it. So anyway, let's see what we can come up with. Now, the first thing I'm going to do is, let's have a look. I'm going to get rid of this. I'm going to delete a lot of the stuff. A lot of the stuff that I did. In fact, should I delete it? Yeah, I should delete it. I'm literally going to start again. Output data received. I think I was wiring this in. Yeah, I was. So I'm going to get rid of that. I'll keep the interact stuff because we do need a flag that indicates whether we're interacting. Writing, I think, is going to remain pretty much the same. And I will change this thing here. So I'll leave that there, but we'll come back to that. We are going to get rid of this whole function here. And I know I'll end up regretting removing some of this stuff, but I want to start with a clean slate. Okay, so we're going to get rid of this output buffer. We're going to get rid of that output buffer as well. Okay, so now to begin with, we are just going to start working on standard out. We know that standard in kind of works based on what we were doing here, right? We just kind of write directly to the standard input stream. You notice how we're actually doing this current encoding get string. So we're actually converting whatever we get given to a string, which I'm going to rejig. We're going to change that to something else. In fact, we may as well. Should we do that first? No, I'll leave that alone. I'll leave that alone for now. Let's continue. So these things do need to be in place. We do need to say that we're going to use shell execute or disable the use of shell execute. We're also going to force the redirection of the streams because without these flags set, we just can't do what we're looking to do. So fail train there, you know, Archbishop, that's why I call this machine the fail train. Anyway, let's get rid of, I'm sure there's a lot of crap in here that I don't need. All right, so we're going to start with an output thread. Now, what we're about to implement is exactly what I did behind the scenes in a test project, which I was playing with because I really wanted to figure out what was going on. And I'll try and take you through the thought process and the steps that I went through to the best of my ability. Hey, Tom. Thanks for coming on stream. Okay, so where did we get to as well with our sys process? Itchy eye. Okay, so what we need to do, this needs to remain the same. So we need to start the process and then we need to invoke something else behind the scenes after the process has started. I think we may actually rejig this very slightly as well, but we'll see. We'll see how we go. We can't really start doing anything as far as interacting with the process is concerned until the process has started. So there's no hurt in doing this after the fact. All right. So once the process has started, we actually want to kick off a separate thread that's going to handle all of this stuff. Did we just get another follower? We did. ZV1 Esda. I don't know how to pronounce that, but thank you for the follow. That's very kind. So when we kick off, we're going to start the process and then we're going to start a thread to handle the output that comes off standard out. Okay. That is important because if we use the built-in mechanisms, we're kind of still stuck with handling strings. And waiting for new lines, which don't always come at the end of the line, such as when we're dealing with command.exe. Okay, so we're going to have, what we're going to do here is we're going to go this dot output thread equals new thread. And it will have a new parameterized thread start. And we're going to pass in, what should we go? This dot process. We'll just say process output for now. Okay. Put it down, and I'll leave it here so that we can do it right next to it, and then I'll rejig the code afterwards. But this process output. Or maybe I should call it, we'll go output received. And object state. So that will actually give us a reference to whatever it is that we kick the thread off with. So when the process is started, what we want to do is start the process, and we want to effectively have that thread running behind the scenes looking for stuff that's coming in off standard out. Okay, so we're going to go this dot output thread dot start. Now what was going to pass in, what I'm going to do at this point here is I'm going to pass in the stream that we're going to be doing things on, because we're actually going to use this as a bit of an abstraction. Okay, so we're going to go this dot process dot standard output. Okay, so we're going to be passing in the stream that we want to listen on. Okay, so output received bar stream equals, I believe it is, what is it, it's just a stream reader. So we'll cast this to a stream reader. Okay, so because what we're going to do is we'll reuse this for standard error as well. Okay, we already had have a reference to the process because the process itself is actually encapsulated in this class. But for this thread of execution, we want to know, we basically want to make sure that we're dealing with the right stream. Okay, I'm going to move that out of the way so that I can see the chats. Okay. All right, so once we've got that and that's kicked off, we're just going to effectively sit here on this thread and we're going to wait. Okay. Now, I've just so you know, I've got my reference off here to the side, and I'm going to tell you what I did when I first started. It's like what I want to do is I want to loop while the process hasn't exited. Okay, so we're going to keep going here, and while we haven't exited, we're going to process the input. Okay. Now, what I started with was, is this, and sorry, not exited. It's called has exited. And then I thought, okay, while process, sorry, not process, while the stream peak, there's a peak function here, right? We looked at this last time. So while that's not -1, because -1 is what gets returned when we reach the end of the stream, we're actually going to read the stream. So we're going to read that single byte, okay? And then we want to, because that's coming in from standard out, we want to keep reading those bytes somewhere, okay? So at this point I thought, oh, okay, well, if we're going to read a bunch of bytes off the stream, we should have some kind of buffer to store them in, but we don't know how big that's going to be. So I thought we will create a buffer, and that's going to be a memory stream that we're going to use to write this magic stuff to. And we'll wrap it up in a using statement to make sure that our resources are freed. So here I just go write byte, because that's actually what we've just received is a byte. We're going to cast that character to a byte, right? Now, while that's actually happening, we're going to be reading a number of bytes off the wire, yeah? And then when that's done, we actually want to write the contents of that buffer to the output, right? So this is where we're going to add a packet, okay? So write out a packet. Now I know we had that, I've just deleted it, so I'm going to read it from here again, because this is basically what we're looking to do, right? Create a core channel write with all of the bits. But the difference here is that we need to cast this thing to an array, because we've got this buffer and we don't know how big it is. We're going to go var data equals buffer.toArray. So that's going to give us an array of the data, and here we're going to pass the data in, and we're not going to give it a size. We're going to say do the whole thing, at which point actually I can just go buffer.toArray like so, and that should do what we want it to do. You would think so, right? This comes with a few provisos. Where's my tea? One proviso is that this isn't going to block, which it will. Oh, sorry, that it is going to block. But in that repeated reading of this will actually allow us to function how we would expect. But what I found is that that's not actually true. Okay, and in this current setup, it doesn't work. So hang on, let's just build that. Get rid of any compiler errors that may come in. Closing, that's true. We'll come back to closing in just a minute. Yeah, I know. I hate it when things aren't true. Oh, wow. Well, thank you very much again for the sub, my friend. You are a legend. Your support is always appreciated. Okay, so what we're going to do is we're going to support this notion, but there's one extra thing that we need to change. I'm going to build that. I've actually had to also change the IP address and whatnot of this because my VMs decided to change again, but that happened behind the scenes, and firing this up should just give us a shell. Sessions -1. Yeah, okay. So now if I type shell here, look at that. You think, oh, it's working. Who am I? What's going on? Why is it not working? So this is where I got to in my little test project. I was like, this is bizarre. Anyway, cut a long story short, what I found was if you check along the way, rather than just checking to see if the process has exited, if you also check that the stream has not made it to the end, we get very different behavior. So I'm going to build this. Alright, so now if I type shell, here am I? Look at that. Now explain to me why. Why is this the case? Why is it that adding this made it work? Because I stumbled on this, but I also changed one thing just a little bit. Is I thought it would be good to actually flush things out line by line, so that we can simulate line by line. Important to check if the process exited at all. Well, I mean, we will be doing that too. And there'll also be an event that we're going to be subscribing to in just a minute, but we're purely dealing with just the output at this stage, right? Which I just don't get it. I don't get why that worked. Ahmed8686, thank you for the follow, my friend. So anyway, what I was doing was this, right? If the character was a new line, we break. So in doing this, we can simulate sending more packets when we receive new lines, which would be, a little more interactive. We are currently working specifically on process channels, but thank you, Rasta, for the bang what. That explains what we're doing at a higher level. So let's see what happens when we do this. Shell task list. Now, have you noticed this? Every now and then we don't actually get what we think we're going to get. See that? It's a little bit messed up, isn't it? I don't know why this console doesn't appear on a new line, but I also think that has something to do with the output. So if we go like DIRC system, not system, Windows system 32, it actually works fine. I think it's the task list output that's not. See that? Now, I put the line by line thing in there because I thought, well, that actually makes a little bit of sense. But the problem is that we end up with a TLD packet every time we hit a new line. Okay? So when I type exit, see how nothing happens? We're going to fix that too. So instead, I am going to remove this for now. And we're just going to reduce the number of packets. All right, so let's rebuild that. Is the output that is unread buffered in the stream even after the process quits? That's a great question. But remember, the difference between the process that we're invoking and the process we're interacting with, well, there is one. We're talking to cmd.exe. We're not talking to task list. We're talking to cmd.exe, and cmd.exe is what's giving us the output of task list on its standard out. Right? So let's run that again. And if we go DIRC Windows System 32, it works just as well, right? Even without those new lines added. So as far as I'm concerned, like that's doing exactly what the native Meterp does, except for the fact that you can't exit. All right, so now what we're going to do is we're just going to add one little thing. One thing we should probably do. Oh no, that's okay. We're only dealing with output here, so that's not a problem. We want to be able to subscribe to when the process fails, right? So we want to say this dot process dot where is it? Is it on exit? Exited. So we're going to add. So we've got, what is it? object sender event args. We're going to go this dot output thread dot kill. Abort. We'll just abort the thread. It's pretty gross. We're just going to abort it. Like so. Is that... Have I got the syntax right? Yeah, I do. There we go. So that means that that should terminate the process, at which point we should be able to indicate that the channel has closed. All right. So what we should probably do is do the right thing. Ugh. Private void process ended. So let's do this. Actually, let's not call it ended. We'll call it exited. And we will subscribe to that. This dot process exited. And we need object sender event args e. We don't really care about anything else, do we? Well, what we need to be able to do is go this dot output thread dot abort. We're just going to brutally abort it. And then once we've done that, we need to actually say that we've killed off the channel, right? So what is it that we want to do? We need to kill the channel off, which should be done by the parent. Is it actually doing that? It's not process. We want the channel manager, don't we? Fire closed event on closed invoke. So the channel manager itself should be able to fire off the channel closed message for us. Here we go. So process channel at this point here. Process has exited. We want to go this dot, I should say base dot fire closed event. All right, so that should launch the close event, resulting in the channel being closed. Does that make sense? All right, sessions -1 shell. Seems to be working. And what happens there? Exit. Didn't actually exit, did it? Well, maybe it's because we've actually got things going on in the wrong order. Let's fire that off again. This is one thing I hadn't done on my little off to the side experiment. Okay, so process exited has not actually been fired. I wonder why. Any thoughts? Actually, you know what we should probably do? Is instead of that, we should do this. Let's go. So let me just make sure we haven't gone ask about face here. So when the channel's closed, we don't actually say to the channel that you are now closed. When we forcibly close the channel, here we are going process kill. So we actually want to know that the process has been killed, and for some reason it's not working. Have we got the right type? Maybe the type is wrong. Plus equals. No, it is the right type. I wonder why this is the case. What are you doing? Here we go. So this event doesn't appear to be firing. Why is that? Anyone got any ideas? I guess not. It's all down to me. That's fine. Yeah, nope. I don't get it either. I would have assumed that I would have got an event indicating that that thread has exited. What I am going to do though is while we're sitting here thinking, I'm going to do this. Right, so we're going to have two. We're going to have an output thread and an error thread. And instead of standard output, we're going to have standard error. Hey, Splat. So that means we can kind of do exactly the same thing for both of these threads. Alright, and that should have, we will then have two threads, one handling standard error, one handling standard out. That should effectively do the same thing. Now when I was doing my reading, there was some discussion around how you should make sure that you're only reading / writing from one to another, but our stuff is channelized. We're actually writing on different channels, so I don't see how this would overlap. So I'm not going to do anything to separate those two streams. Apparently you have to set enable raising events to true. Really? Well, is that on the process itself? Process.enable raising events. This.process.enable. Well. Thank you, Tom. Isn't that stupid? Yeah, I want events, please. Because I did this behind the scenes, right? And I didn't enable that enable raising events flag, and kind of functioned as I was expecting. Well, let's test Tom's code. And remember, if it doesn't work, it's Tom's fault. That'll teach you for contributing, Tom. Thanks, dude. Super helpful. I really appreciate that. Ooh. What happened? Have I got a breakpoint somewhere? Ah, I've got to create the object. Who is this idiot? Coding is hard, you know. You know what? If you think coding is hard, I highly recommend coding in front of other people you can't see. And then when you go back to coding, you think, man, this is easy because I don't have people watching. It is still kind of weird. Okay, here we go. Hey, there we go. Thanks, Tom. Nailed it, mate. Crushed it. We've done it. Process stuff done. How good is that? That's good. We've it looks like we've kind of got to where we want to, right? That's pretty cool, don't you reckon? Now to do PID spoofing. Yeah. Well, let's make sure that we've got the basics of the channelization stuff working. I don't see any other messages coming through. We've got core channel, right? Have we done the get in thing? Yeah, I guess we have. Huzzah, indeed. So it didn't actually turn out to be that bad, but you know, this thing here, this end of stream check. Yeah, no, I totally hear. It's also going to be a real pain in the ass when it comes to thread impersonation, because you know, Meterpreter uses whatever the current token is to impersonate the user when it kicks the process off. So I may even have to resort to going native just to create a process. We'll come back to PID spoofing, I think, once I've done a bit of reading on the options, and then we'll look to implement it on stream. But reading about it on stream? Yeah, I don't know. Anyway, we don't need this closing flag. We can make this read-only, and we can make this read-only. Ah, the interactive thing. Yes. Interactivity. So we need to put something around interactivity. Because while we're not interactive, we don't actually want to do anything with this data, right? So, while stream. So we can do all this. Basically what we want to do is at the point that they specify no interactivity, we just want to stop sending packets, really. So if this dot interactive, send a packet. Which shouldn't really matter, but it does beg the question, the chance of there being a very small potential of a race condition in the early days. Hey, Multi. So if you type shell, do you lose anything? Yeah, you do. So, I mean, according to what we see behind the scenes, we should have got core channel. There you go, core channel interact. We get this core channel interact after we've sent some packets, or after we've read some stuff in. So the question here is, do we, once we've written a packet, do we flush the existing buffer, and do we still capture things behind the scenes? Because the native implementation behaves very differently. I don't know whether you remember. Let's quickly have a quick squiz at that. Where are we? Payloads. So we go request core channel interact. Huh? God damn it. Core. Sorry, I'm hopeless. Process. Execute. That's what we want. Did we just have another follower? I think we did. Louis SG or Lewis SG, thank you for the follow. Just got to find the right remote sysprocess execute. Let's quickly go to the definition of this thing. Request sysprocess execute. All right, so there'll be an interactive flag here. Okay, so when we say interact, what happens? Let's go and look at the implementation of that. Okay, so here we go. The remote side wants to interact with us to schedule the standard out handle as a waitable item. Okay, so we are interested in the data that comes off standard out. Okay, so we're probably going to have to be a little bit smarter then. What we should probably do is have some signals in place, because we don't want to lose data. I don't know why I did that. We don't want to lose the information that's coming in off the wire, right? If we're starting without being interactive, then we shouldn't be reading any information at all off the wire, should we? So, rather than doing this, we'll leave this as it was. And what we're going to do is when we come into output received, we're going to say if this dot interactive. So if we're not interactive, we need to wait. Okay. So what we're going to do is we're going to create an event, a little event handle thingo, like a signal. We're going to go private read only. What is the object type? Mutex. Synchronization primitive, that can also be used for interprocess. Now we don't want the interprocess comms. That's not what we want. We just want to be able to have a signal event. Or an auto reset event. That's what I want. I want an auto reset event. So this is the interactive event. Okay. And here we're going to go this dot interactive event equals new auto reset event. Initial state is not signaled. The default should be fine. false. So an auto reset event says when the signal is set, it'll go back to not being signaled, so we don't actually have to do the manual resetting. So here what we're going to do is go this.interactive event.wait1. Okay. Now what we'll do is probably going to make sense to do it inside the loop, right? We might move this down to here. Because inside the loop, we could kind of become interactive, right? So we want to wait. And it might make sense to have a timeout in here. Because if the process executes, then, if the process ends, then we don't want to sit here forever, yeah? So maybe we'll have a timeout here. So we've got, what do we got? Milliseconds timeout. We could time out after like 500 milliseconds. And then if we are interactive, we can go ahead and do what we need to do. Otherwise, we'll just bomb out, come back around here, check to see if the process is executing, and off we go. So that means we're not going to lose anything. It's all going to be kind of piling up behind the scenes. Oh, excuse me. Now the real question is, like, should we be taking stuff off the channel while it's happening? I don't know. I feel like saying launch a process and then go interactive after the fact is not what we should be doing, but it is what Meterpreter does, so whether we like it or not, I think we're stuck with it. Let's see what this does. You guys used events in .NET before? Shell. There you go. So that actually caught the stuff. And when we exit, it should bail out. Shell. And if we sit here and go, it should still look legitimate. So there should have been a bunch of timeouts behind the scenes. Every half second, it's quickly looking to see if there's any stuff. Yeah, events are great, aren't they? So yeah, it works. One thing that I wish I could do away with is this echo of CD. You know? So let's exit out of that. So like when we run CMD, if we type CD, see how like this doesn't actually, I mean, it does technically get written to standard out because it's echoed to standard out before you hit enter. What I'd like to see is some smarts that go, hang on, you're coughing back at me the stuff that I typed in. But it's so specific to the process and the context that you could end up removing stuff that you shouldn't be removing. So we're not going to worry. We're just going to leave it. Anyway, any questions? Do we have any questions about what we've done? Other than, dear God, what were you thinking? First world problems, yeah, pretty much. Yeah, Ben, I hear you, man. I see that all the time. It's filthy, but command.exe echoes it out. So, you know, we can't legitimately say whether or not the stuff that we've been sent contains the output of what we've pumped in. Can't you just still turn echo off in command? Can you? Don't know. Maybe you can. Is that a thing? How do you do that, Atwolf? Ah, as in like the classic. Really? But then we end up losing the prompt. Let's see what that does inside our shell. Hey? That'd be cool. For some reason, I didn't connect the dots when you were saying echo off. There you go. We lose our prompt. And we still get the stuff back. No, that's not really what I was hoping for, which is a little bit upsetting. GG's. I kind of did the exact opposite, didn't it? We lost all the output of the console, but we didn't get the Weird. I know. Go figure. It's not me. Anyway, I think we've had a win there, folks. With process command execution and whatnot done, I think we're ready to move on. But let's have a look to make sure that we haven't done anything silly. Wait on a process handle. Okay, so that's basically the async thing that says, you know, make sure that we can kill off. Oh no, this is actually something separate. Sys process wait? I didn't even know this was a thing. Hang on a sec. I wonder if that's like literally the only reference to that code. Oh no, there is. There is a stand API sys process. Wait, I've just learned something new. Let's take a look at where that goes. Code. Metasploit framework. Really? Isn't this amazing? I did not realize. Wow. Block until this process terminates on the remote side, and by default we choose not to allow the packet response timeout to occur, as we may be waiting indefinitely. Well, well, well. I did not know that was there. Did you know that? So, block until this process terminates. And it's giving, what is it giving? It's giving the handle. Okay, so does that mean that in order to support, because we probably should be looking to support whatever this feature is supporting. TD type handle. Ah, so you can open a process through attach. Isn't that interesting? Block until this process terminates on the right side. Get info. Yeah, there's a whole raft of process related stuff there, which isn't, I guess it probably is in some ways channel-y, but yeah, I'm quite surprised by that, folks. That is code that I did not know was there. I mean, I get the whole open process thing, so attaching is connecting to an existing process. Get processes, process get PID, get info. So get info is a completely different thing, which we can work on outside, but yeah, there you go. Go on, boss. Welcome, sir. Yeah, I'm blown away. I'm blown away. I just learned some stuff. That's really quite bizarre. Okay. Anyway, I digress. Let's remain focused. Let's have a quick look at what else that we didn't include in our implementation that should have been included based on what we see in the native implementation. Where is it? Process execute flag use thread token. Okay, so this is the thing I think that does the here we go, creating a process as a user by manipulating tokens. This is the thing I'm probably going to need to go and have a squiz at outside of the stream, because I could end up just sitting on stream reading documentation, and that's not exactly exciting to watch. So we'll have a think about how we can implement this. Yeah, it's probably going to end up with a bit of p invoking, but yeah, we'll see. There might be a create processes user kind of facility, but yeah, I don't know. Rasta loves a bit of p invoke. Anyway, let's quit out of that. So what do we got left as far as the process channeling thing is concerned? Oh, actually, hang on. So if we go shell, if we press Control Z, what happens? Background the channel. Okay, so that should have said behind the scenes, turn interact off. See that? So we executed, we turned it on. We should actually see what this does. Hang on, let me rebuild. Spin that up again. This one, shell. Did I hit enter? No, I didn't. There you go. So that says set interact to true. Okay, so if we go Control Z, background the channel, interact false. So was that, hang on, we've got 3. Where did that third one come from? Oh, do we need to actually acknowledge it? I don't think we do we? Let's have a quick look. Interact. Let me see. Enable or disable interactivity with output. Okay, so just signal the waitable and return the result. Okay. Process channel interact. So that gets wired in magically, right? Okay, so we need to go request core channel interact. Why is it that I always get those function names wrong? Remote request. Really? That's upsetting. Okay, so that's what we want, this one here. Okay, so it gets that, passes it on, set channel interactive, lock release. It just returns an empty result. Is that all it's doing? It's not actually adding any TLV values, is it? Packet create response. And I think that's what we're doing, isn't it? Channel manager, channel interact. There you go. We do return a result. I'm confused. Are you on mobile Twitch? That's a bit rough, Wolf. Channels, channel-L. Channel-H. So then we can go back and interact with channel 1. Who am I? Ah, should have got this. Okay, so that does work. We can kind of go back and forth, which is exactly what we want. I am very confused though, because why are we getting multiple interact notifications? Background. Interact is false. And it comes in again. What? I am confused. Anyway, there is something that I think we need to do though, because hang on. Yeah, so the wait one at the moment will continue to spin in here. What I technically should do by proxy is go if this, hang on. So if we're going from uninteractive to interactive, and not this dot interactive. We want to know if we need to fire the event. So fire event equals if we are supposed to interact and we're coming out of not being interactive, we then set the interactive flag because that's going to be something that we'll use after the fact. And if we fire the event, and this dot interact event dot set, we actually want to stop whatever's waiting on it. Now we've actually got multiple threads waiting on this, so this is it a problem? Maybe it is because we're actually handling, we've got two different threads waiting on the same event. And we want to make sure they both get the signal. So maybe we should be using a semaphore. Yeah. Right, because we're allowing two at the same time, right? Read only semaphore. Interactive semaphore. So this dot equals new. Initial count is 0, maximum count is 2. So then, instead of waiting for the interactive event, which we're no longer using, we're going to say, oh, did I type it wrong? Oh yes, I did, thank you. Semaphore. Thank you, Tom. Okay, so we should have a wait one here as well. So yeah, we can leave that as is. All right. So then when we indicate here that the interactive semaphore, we need to release basically this dot interactive semaphore. Is there should be a count, right? Size. No. Oh well. I was going to say let's use the size instead of a hard-coded 2. But we know we're dealing with 2 streams, so oops. Indicate to both threads that they can continue processing as we have gone interactive. Make sense? So yeah, our interactive semaphore, a mutex for both threads that handle standard out, standard error. Is everyone familiar with semaphores, by the way? Let's see how much I've broken by doing this. Thought it was music. Who am I? Z, yes. Did we get multiple? I'm amazed. Why are we getting 2? We get 2 indications. This is not OJ. I didn't see you sneak in. How you going? Is it possible that the standard out thread could grab the same semaphore twice and leave standard out hanging depending on scheduling? That is a remote possibility. But I think that it's less of a possibility given that our threads are waiting for 500 milliseconds. But yeah, I don't see that as a scenario. I mean, I guess what we could do in that regard, because remember, like behind the scenes, when you're using a semaphore and two threads are waiting on the same semaphore, there's still prioritization. So there's like a queue behind the scenes. So I don't necessarily think, and I'd have to check this, that let's say standard out receives the semaphore and goes to the back of the queue if it starts waiting on the semaphore again. In this scenario, this would require us to go from interactive, then back off interactive really quickly for, I think, this to raise its head. But no, I think the reason why semaphores are a thing and the way that they work is the way that they work is because yeah, because they do like a queuing mechanism behind the scenes. So hang on, maybe with the semaphore, it might actually return a value. Let's have a look. Blocks the current thread until the wait handle receives a signal using 30% signage to specify the time interval. Time span, that's just to do with, what is exit context? Yeah, okay, whatever. True to exit the synchronization domain for the context before the wait, the synchronization context, and reacquire it afterwards. Yeah, we don't need to worry about that. We've had another follow from Huntsman West. That name is familiar. Thank you for the follow. How's it going, dude? Kids being too slow, take out of the vid. Good night, Civilized. Thanks for coming on. Okay, all right. I think that's probably a more reasonable stance to have on this whole thing, and we might at this stage move on. So the next thing that we could look at should probably go back to looking at other types of like TCP channeling. The thing is that there's a lot of features for channels sort of behind the scenes, and I know that not all of the Meterps implement all of them, but I don't want to go through and just create a sort of half-baked version of each of these things. So I really should make sure that we've supported all of the things that we claim that we're going to support. So with the process channeling out of the way, what do we got? We've got an hour to go. We could go ahead and try and implement server-based channels. So we set a listener, which is effectively used for reverse port forwards. Or we can go back to the TCP stuff and make sure that we implement all of the extra flags that you can specify on the socket. I mean, there's this notion of buffered sockets, which I haven't really looked into. Or should we work to get another channel type out? What do you want to do? We could probably bash out the server channel stuff pretty quickly. What's the thoughts? Smash it out? I think we probably should. Smash it out. Ah, Wilbatross is here as well. Sneaky. All of you people are so sneaky. All right. Oh, have we actually? Yeah, we have done transport ads. Actually, at some point soon, you know what else we need to do? We're going to add support for pivots. Yeah. Hey now, you're a server port. Get the stream on. Go play. Hey now. See, are you putting new lyrics to Smash Mouth, Tom? You people disgust me. You should be ashamed of yourselves. Alright. What I'm going to do first is I'm just going to fire this off. Let's make sure there's no breakpoints. I'm going to fire this off. Alright, so when we did port forwards before, we did port forward add. Now, what we did was we wanted to listen on like 8888, forward to 9999, and where are we? We need to specify R, the remote host to connect to. Now, this time it's the other way around, right? Because like our local local endpoint here is the one we're going to connect on. P is the one we're going to listen to. So that means -R isn't required for this. But we can, hang on, where are we? Forward. If we specify -R, that should be enough. Must apply a local port, okay, so hang on. Local host to listen on, optional. Reverse local host to connect to. So we are specifying a reverse port for. We need to give this local host to connect to. So when things come in, we want to connect to ourselves because we're going to set up a listener. We'll have a listener sitting here. Okay, so we're going to go NCLEP. Now, what are we? We're listening on 8888. Okay, so then when we execute this, nothing should happen. Core channel open operation failed. So that doesn't surprise me because we're not actually doing all of the things that we should be doing. So core channel open gets invoked, which isn't surprising. Where are we? Channel manager is what I'm looking for. Where are you? Channel manager. Okay, so core channel, does it actually do a core channel open? Yeah, I guess it does. Now, that's what we needed to do. We needed to log. So what we can do is go else system.diagnostics.debug. No, not debugger. Debug.writeLine. String.format. Do I need a string.format here, or can I? Yeah, I do. String.format. Okay, so we'll go core channel open. Unable to create type 0. And channel type is a string. All right, let's see what that comes out as now. Unable to create type standard API net TCP server. Okay, so what I want to do at this point, let's take a quick copy of that and look at the native version. Because I want to make sure that we understand that like one channel versus another and how that actually behaves. Because with the client channels, we didn't actually create a channel in Meterpreter until we actually had a connection come in, right? Now, where are we? Request net TCP. It must be. Surely it's in here. Yeah, here we go. Righto. So, does it actually create a channel at this point? So I'm just doing a quick squiz. It does create a channel at this point. And the waitable is when a new channel comes in. Yeah, okay. Interesting. Hang on, is that true? Yeah, so we do the classic WinSock stuff. We listen on TCP channels. We try and bind, and we listen. Now this is actually quite interesting because opening the server channel completed successfully. So the reason why I find this interesting is because in my head, we don't actually create a channel until someone connects to the socket, right? So we create the socket, we set a bunch of socket options. That's all just set sockop stuff, which we will start with just IPv4 and then we'll extend it to support IPv6. Binding, exactly what we would expect. Listen, oh, okay, so listen should be fire up and then accept should be asynchronous. Okay, so WSA event select. What does this do? This is like full async. Specifies an event object to be associated with a specified set of file descriptors. Okay, right. So this is creating event objects. Yeah, that makes way more sense to me now. So this function call, hang on, where is it? Here we go. This creates waitable handles for this socket descriptor. And then it queues the waitables here. Okay, so we get this TCP channel server notify, which is here. So this should have notify routine for a TCP server channel pick up as new client connections. Okay, so what this means is that this should get invoked at the point where a new client has come in. Okay, and that's when we call accept. So it's like an async accept. Yeah. Thank you. This is not OJ. Much appreciated. It's nice to have you on stream as always. Okay, so this doesn't look too bad. This actually fits maybe a little more with what I was expecting. What I don't get though, hang on a second. Like, well, how is it that we tell, like this is effectively a new channel? So what do we do when we send information back? What kind of packet are we creating? Reset that event so that we get more accepts asynchronously. We accept it. And then if that works, great. TCP server, channel server, create client. Okay, so that then operates as, I would assume, a client channel. But we'll have a look at that in just a minute. That just associates information, etc. Packet create TCP channel open. What on earth is this? Okay, this is upsetting because this has all kinds of connotations for removing strings from TLB packets. I'll come back to that. That's not an issue that we need to cover on stream right now. We will come back to that. So clearly we're creating a new packet of TCP channel open. And I think what I've done behind the scenes is change that to standard API TCP channel open because it is a standard API thing. But that's okay. Sorry, my mind's wandering off. So TCP channel open, we specify the ID that's related to the client. Okay, so that's fine. That's also fine. Okay, so this doesn't look too bad. All right, let's get started on that then. Righto, so let's open this up. And we'll create a new item called a TCP server channel. I kind of get the idea why this is a channel now, because you do want to be able to sort of interact with it in some way, such as killing it off. But anyway, this is going to be a channel. It's a core.channel. Now we need to implement those things. Now, here's an interesting thing. Like, what happens when you write to that channel at this stage? we are not going to do anything because the idea of writing to the server channel doesn't make sense. So maybe we'll return that because we should never actually see this happen. We also need to go bytes written is 0 because of the out keyword here forcing you to set it. Alright. What else do we need to do? String. Oh no, we don't need to do any of those things. It's complaining about something. So I'll leave that there for now. And then yeah, we need a constructor. Now to do what we did with the TCP client channels, we're going to actually make this protected and we'll be doing the same kind of thing. And we'll have a create method like this. Okay, so we're going to go public static TCP server channel. Okay. Now what we want to do is we need to be able to pull apart all the stuff that's coming in off the server channel creation routines. Now, hang on a minute. Let me just quickly go back to... open this again in a new tab. And go back to the previous. Here we go. Pretty sure it was in here. For channel open. Where did we get it from? Channel create. It was this one here, wasn't it? I'm tying myself in knots again. TCP server, create client, notify. Here we go. This one here is the one that we want. Okay, so let's pull out the same bits and pieces that we're looking for. So local port and local host are specified. Feel free to skip it, it's too mundane, but what's the server channel mean in Meterpreter? Not really sure why you wouldn't write to this one. Yeah, okay. All right, Tom, so I'm still a little vague as to why this should be called a channel, because to me a channel is something that you would shuffle data back and forth over, right? I think the reason why that a server channel in this context is actually a channel has got something to do with the fact that there's a waitable behind the scenes, and rather than putting some other kind of like server style abstraction in there that would allow you to interact with it, it was easier to just bundle it up in the context of a channel. But to answer your question directly, what we're saying here is we want to tell Meterpreter to kick off a listener on a port, and we need a way of identifying that listener, and so the channel abstraction is just a way of identifying that listener. So what happens is when the listener is invoked, we have a channel that identifies that listener as a TCP server. There's an identifier associated with that server. Okay, so that's sitting there listening on a port. Now the problem is that we don't really have the means to send data back and forth across that server channel because there's nothing talking to it. It's just sitting there listening. Well, what happens is when a TCP connection comes in and connects to the server, what happens is we need to wrap that connection up in a TCP client and then create a new channel with Metasploit saying, hey, we've got the means to talk back and forth now. Right? And we sort of bundle that up as part of the TCP client channel. I would assume that would make the most sense because that's got all the functionality for actually doing the shuffling of the data back and forth across the channel. So when that TCP client channel has been created by the server, that goes off and does its own thing, and then the server goes back to waiting. So even though there's no data, like it's not shuffling any data, but it's responsible for serving. So the idea of writing to that channel, actual data writing to that server channel, that just doesn't make sense in this context because it's not responsible for shuffling information back and forth. It's only responsible for listening and creating new clients. Does that make sense? I don't know whether I described that very well. In fact, I'm pretty sure I didn't. So if that was confusing, tell me and I will try to do a better job of explaining. Okay, so we need the local port and local host. Do we need the local host? I think you need a picture. That kind of means I got to draw, and I'm not very good at drawing. Whiteboard. Is there like a free online whiteboard? Online whiteboard, let's have a look at that. Okay, that's not great. Online whiteboard with real-time collaboration. Get the basics here. You made a listen socket and you... Yeah, exactly. Yeah, exactly that, Tom. Start drawing. Oh, holy moly. How do I get rid of all of this noise? That's, yeah, here we go. Right. Okay, so. Do you guys really want me to do this? Okay. So that's Meterpreter. And that's Metasploit Framework. It's too late to go. Ironically, the handwriting that I've just displayed is probably neater than my real life handwriting. Okay, so we have an active connection which between these two components, which I'm not going to draw because that'll just add noise. So just pretend that these two things have an active TCP connection between them or some kind of transport which allows them to communicate. Okay? All right. So what we want to do from the MSF side is we want to send over something here that says, I want you to create a listener. So that's what the core channel open message says. Okay, so we're going to listen here on port 9999, right? So that's where our listener is. And that listener needs to have a channel associated with it, right? So that virtual channel that is able to talk back and forth to MSF actually doesn't have the means to actually write data back and forth. So we've got a listener here, but there has been no client that's come in and connected yet, despite the fact that there's a channel at this end and there's a channel at this end that communicate, right? So that is we'll call this a server channel, okay? So when a client comes in, I tell you what, writing with a mouse is hard. Client comes in, okay? And then what happens is the call to accept happens. So that gets invoked, okay? Accept then says, right, let's create a client channel, right? And then that object there basically gets sent back over here to MSF. And that is basically a TCP client channel. Okay. So from here, okay, once this notification has come across to Meterpreter, and it has all of the wiring that it needs at this end, information can get sent along here and get sent back in this direction as all of this stuff comes in. Like so, as the client sends messages, it comes through here and goes this way. And then from MSF, it can do the same. It'll go this way and back out through the client. Okay? But there's no information that comes through the server. The server is still sitting here listening. And again, when a new connection comes in, Another one of these will get routed through this way. But again, nothing actually goes over this channel. So there's no reading or writing at all across this channel. It's all done through these client channels. Does that make sense? Did that help? Did my legit drawing and terrible handwriting live on stream clarify that anymore? I hope it did. Because don't make me do it again. How embarrassing. Is that good? So you can see like it's all through these new client channels, but the original channel is left alone. And I think the reason why this mechanism is used as a channel is because it kind of allows for this to make use of the scheduling mechanism that's built in behind the scenes that comes with channels. And it means that at the point where you say, you know what, I don't want the listener anymore, you can literally send a, channel close message across the wire, and you signal the waitable and say, oh, we've had a message come in for closing, and then you can just terminate the listener. And so the channel mechanism kind of allows you to do that. The only abstraction that leaks into this that doesn't make sense is the reading and writing. I am absolutely not. And poof, it's gone. What a shame. It will be forever preserved on stream. All right. Basically describe half. That's true. Thank you. All right. So back. Let's focus, people. All right. So this local host thing here is interesting to me because we kind of I assumed that we were going to just sort of listen on all interfaces. Right. So if localhost isn't specified, we bind to anything. Otherwise, we use what was specified. Okay. So that makes a bit more sense. So type localhost. Let's start with that. var localhost equals TLVs dot try get. Hang on. TLVs. Oh, I haven't even put them in there. I'm so inconsistent with how I pull values out of TLVs. Where's the process channel? Because I know I do it in here. Try get TLV as raw. All right, let's quickly refactor the client channel. Dot try get value as string. Now we should be able to include extensions. Come on, talk to me. Why aren't you talking to me? Extensions. There we go. And now that should work. Is that not how it works? I don't even know my own code. Try. I don't know what's going on, but for some reason my keyboard has gone all strange. Works there. Okay, works there. Try get. Okay. Request.tlvs.try get. It's try get TLV value. I'm so dumb. Try get. Maybe I should rename it because I think that's bitten me before. Try get TLV value as string. Okay, there we go. Request try get TLV value as dword. Okay. Try get TLV value as D word. Let's do this here as well. DT boom and boom. There we go. That's a little easier to read, I think. So that's what we're looking to do. Hang on, that shouldn't be flags. That should be channel class. Should this be just plain old flags or channel flags? Yeah, that's just plain old flags. We've already checked that. Okay. Okay, that solves that problem. Try get TLV value as string. And this is going to be TLV type. What is the TLV type? Localhost. Standard API, localhost. Alright, back on track. Sorry about that. So we need localhost and we need local port. Sees value as, that'll be a D word. I assume it's probably going to be a short though, isn't it? A local port. So we should probably U short that or short it. Maybe it's just plain old short should be enough. Yeah, it's a unsigned short. There we go. U short. Okay. Then it just goes off and creates the socket, which is fine. We're not going to do that now because the abstractions are a little bit different. So, once we've got that, what else do we need to give it? Is there anything extra? I don't think we need anything more at this point. Localhost and local port is pretty much all we need. So we should be able to go return. Let's go, that's going to be private. Return new TCP server channel. Packet dispatcher. Pass the packet dispatcher down so that it can dispatch the packets. Well, you know, you can never be too sure, right? Local host, local port. Should make sure that that's correct. Alright, so string local host, string local port. It's twice I failed there. Create an initialize field. Create an initialize field. Okay. Now, with that in mind, we now need to effectively kick off. Oops. That's not going to be a string, is it? It's a U short. Easy done. Okay, so now we need to kick off the server thread. So what does a TCP server actually look like? We're probably going to need a reference to it, aren't we? This.tcp server equals new. System.net.tcp sockets TCP listener. That's what I want. That's going to be a using sockets. Yep. Okay. So we can create a new one. Port, endpoint, IP address. Okay, so we need to somehow convert the IP into an endpoint if we have one. Righto, so if not string.is null or empty localhost, there needs to be more OJ emotes on Tampa with using channel points. I need to do some emotes, don't I? Private read-only TCP listener. I think this is going to be easy, right? So if it's empty, it specs an int. Far out. Like, why is it? Fine, you want ints. Ints is what you get. Okay. Oh, really? The method's been deprecated. Please use IP address, local address. Okay. All right. Fine. Fine. So we're going to need to create an IP address for this. All right. So if that's, we should be able to use like IP address. There should be a static IP address thingo. System.net.ip address. System.net.ip address dot any. So what we're going to do is this. We're going to go bind address equals IP address dot any. Don't do that. Don't do that. And then if we haven't got one specified, we'll overwrite it with something. So I'm assuming that IP address has a parse or something along those lines. This is interesting, isn't it? So what does any give us? Is it just provides an IP indicates the server must listen for client connection on all network interfaces? I wonder if that actually allows us to support things like we'll come back to IPv6 later on. Don't worry. Don't worry. All right, so there's got to be a parse method, and we should be able to give it a string. Winner. This.localhost. All right. That means bind address will be that, and then we can pass bind address in there. Actually, you know what I might do is this, we might even keep, instead of keeping localhost as a string, we might keep an IP address and call that bind address. We can get rid of this localhost and just keep localhost. We can keep track of everything else that way. I mean, technically we could probably get rid of everything here, because I would assume that after this .listener. Has it got address or anything like that on it? Local endpoint dot address family dot okay, that's not what I'm looking for. I just want to see if I can get rid of some of the things that I don't need. Server address family. There's got to be like a blocking connected, enabled, handle. All right, we'll leave it like that for now. Okay, so this .listener is. I wonder if there's a start. Here we go. Start listening. In backlog starts listening for incoming connection requests with a maximum number of pending connections. We won't specify that. I wonder, like that should, is that blocking? This .listener, is there an on? Hang on. Accepts a pending connection request. What I'd like to do, if possible, is just use an event, if there are any events. All right, hang on a sec. Let's quickly look at the docs. TCP listener. That's what I want. Oh, one thing I need to do before I forget is under standard API.NET 4, we need to add an existing item which is standard API.NET 3 channel, server channel, add as link. All right, so let's see what this is doing. Creates a listener with local port address, start listening for client requests, buffer for reading data, enter a listening loop. Okay, so we can do this here. Oh no, we can use the begin accept. Begin accept socket. Begins an asynchronous operation to accept an incoming socket connection attempt. Or we can just say, give us a TCP client. Begins an asynchronous operation accepting an incoming connection attempt. Okay, so that's probably what we're looking for, right? Begin accept TCP client. So we will go this dot, we'll go TCP client connected. State, we probably don't need to give it anything. So at this stage, we're going to go null. Let's go private async callback. So this will be private void TCP client connected. I async result. I assume that's what we're going to be doing. So methods. Let's have a look at the accept TCP client async. Accepts pending connection request. Okay, and that should return. Can I actually use that here? I assume I can because it did come up as a .NET 2 option. Begin accept TCP client. Yeah, okay, so that's fine. That should still work as a .NET 2 thing. Make sure that we are using .NET Framework 3.5. Okay, so accepts pending connection request, and does it really? According to this, it returns an IAsync result. According to the docs here, hang on, the requested page is not available. Accept, okay, so I'm looking at the wrong thing here. So we want to look at the TCP. Sorry, one sec. TCP listener constructor for framework 3. Okay. Now in here we should see begin accept TCP client. There we go. This is what I want. Sorry about that. Okay, so do begin accept TCP. Set the event to non-signal. Okay, so there's like an event signal too. Process the client connection. Get the listener out of the state. Which we don't need because we've already got a reference to it as part of our local object. And then we call end accept. And then we don't begin until we've ended the accept. Okay, so that's fine. So we can handle that. Was it a manual reset or an auto? Yeah, it was a manual reset. Set the event to non-signal. Begin accept and then wait. Yeah. Okay, well, we'll follow the same pattern. We're going to have a manual reset event. Read only. Manual reset event. Listener event. And we will create that here. Listener event is a new manual reset event, and we're going to have it non-signaled. Old sound. Oh my god, is this like the legit old sound? Alvaro Videla, is that you? Oh my god, it's Alvaro. Ladies and gentlemen, we are in the presence of greatness again. I have known Alvaro, although we've never crossed paths. Alvaro and I have known each other for a very long time, and we crossed paths originally through our mutual fanboyism of Erlang. We crossed paths in Erlang, and I distinctly remember the first time that I had a serious interaction with Alvaro. We wwere talking about RabbitMQ. And Alvaro's worked on RabbitMQ. In fact, he's done a lot of fantastic stuff. You should follow this guy on Twitter. He's magic, and he's a wonderful human. So I had some confusing stuff going on with RabbitMQ, and I was new to it. So I basically pinged this guy on Twitter and said, "Hey, you seem to know stuff about RabbitMQ." And within 5 minutes, I shit you not, he fired up a screen share and wrote code live for me personally, showing me how to do things. Like, never met me before, never really spoken to me before, and just say, yeah, let me show you. Screen share, and boom. It was awesome. That is the kind of person that Alvaro is. He is a legend. It's nice to see you, man. And thank you for the follow, too. So, yeah, a lot of security people on stream here, Alvaro. And hopefully you'll get a few follows out of it, because you deserve it, mate. All right, so we'll set this listener event here. And then just as we start doing our begin, just before we begin, we've got to make sure that we reset. So what we'll do, instead of doing this, we'll do private void begin accept connection. We'll just abstract that a little bit. So this dot listener event dot reset, and we'll kick that off, and then we'll make sure this dot listener event dot wait one. We'll wait until that one's been handled before we kick things off again. All right, so we'll go var client connection equals result dot end. No, not result. This dot listener dot end accept TCP client result. Now that could throw an exception, but we'll worry about that. Old Sound, yeah, it is, man. At the moment, my plan is to sort of do most Tuesdays from 8 o'clock. So that we started an hour and 45 minutes ago. And the plan is to sort of maintain that at the very least while we push on through this fun development task. Sometimes, like, I mix it up. Sometimes I do different stuff. But most of the time, Tuesday nights. Tuesday nights is when it happens. All right, so now that we've got a TCP client, we're going to signal the listener event so that the server can begin listening again. If client doesn't equal null, make sure that we've actually got a client. All right, so this is where it's going to get a little bit of fun, because we want to do the same thing. We want to be able to create a channel, and in doing so, we need to wire that into the channel manager, just like we did with the process channel. So when we created one of these, what did we actually do? It was part of the step higher, wasn't it? The sys process, which maintained a reference to the channel manager here, which we don't actually have at this point, but that's okay. Maybe we need to change this packet dispatcher thing so that we maintain a reference to the channel manager itself, which actually has the packet dispatcher property on it. That might be better, hey? Should we do that? In fact, this public reference can probably be made private, and we can have a dispatch function that we can pass in. All right, let's do a quick bit of refactoring here. So instead of creating something that takes an action, where are we? Register channel. A function that takes one of these is not what we're looking for anymore. We're going to go a function that takes a channel manager. All right. Which means we've got to change that. And that will be okay. Now, when we invoke the handlers now, down here, that needs to be a channel manager. And we just, instead of passing in the packet dispatcher, we're just going to pass the cells in as a reference. Alright, so when we build that, that's going to whinge and show me where I need to refactor stuff. There we go. Channel manager. There we go. That's what we're talking about. So TCP channel.create, we can uncomment this now because we'll be doing the same with the server. This is not going to be the packet dispatcher. This is going to be the channel manager. Like so. Channel manager. So we pass that down here. And we end up receiving it here as well. Channel manager. Maintain the reference channel manager. Pass that down to the base because the base is going to change. Because it's going to, instead of having a packet dispatcher, it's just going to have a protected channel manager. Get in private set. Oops. Can't type. Is this all making sense? Right, it's done. Welcome, Benzies. Nice to have you back. I hope all is well. Channel manager. Channel manager. How was your ride, man? Was it good? Okay, so with that done, we should only have to adjust a couple of other spots. So instead of this .packet dispatcher, we're going to have channel manager.dispatch, and we'll pass the packet in. And then channel manager here is not going to have this as public. We'll keep this as private. Okay, like so. And then we'll have a public void dispatch packet. And from there we can just go this .packet dispatcher and fire the packet into it. Yeah, okay, cool. There we go, done. Rupture Reality, thank you for the follow. Shredding berms, hitting jumps, great ride. That's awesome. Hopefully we're going to get close to nailing this server channel stuff before I go to bed, but it's taken a little bit longer because everyone had me doing stuff that I shouldn't be doing. So I was drawing on boards and stuff. Channel manager. Oops. Okay, so from here we can just go this .channel manager.dispatch packet. Okay, we're getting there. Server process channel's done. Server channel needs to be adjusted. Channel manager. You can pass that down. And let's bubble that in here. Come on, Biz Studio, do you think? There we go. Alright, so we can pass that down. Now, bind address is not something that we are maintaining, are we? Yeah, we are, sorry. This dot. Oops. I like to put the thises in, it makes it explicit. Rupture Reality, we are, I'll just do the bang what. so that you know at a high level what it is that we're aiming to do, and at a lower level right now we've just done a little refactor of how references to this field is never used. Really? It is used. I just passed it in there. We're just trying to implement the notion of server channels. Channel manager. Hang on, where are we? Ah, no, this is dispatch. That's right. You're welcome. Please feel free to ask any questions along the way. It can be a little bit confusing, and I know I'm trying to move around a little bit quicker than I normally would because I'm getting close to the end of the stream time and I don't want to be up too late. All right, so now what we need to do is exactly the same as what we did with the sys process, where we see how this we go create, and we've got this manage. Look at that. That's basically what we're looking to do. So we want to be able to go TCP client channel dot, let's go wrap. We want to pass in this dot channel manager because we need to make sure that that's got a reference to it, and the client. Yeah, and we end up with a client channel that should come out of that. And then we can go this dot channel manager dot manage client channel, and that should be good. Now let's chuck that in. Oh, whoa, stop. That's what we want. Public static, that's going to give us a TCP client channel. We're effectively going to do the same thing as this, except that we won't have any of that information handy. See how this just says return a whatever? I wonder if we can extract that directly from things. Peer host equals client dot. What is this? That's the socket. So what I'd like to do is extract this info so that we can maintain it, right? Without necessarily, I think the channel class is something else. So you can use this in Windows instead of just Kali then. Okay, so the aim of this is to provide another implementation of Meterpreter that works natively as a .NET program, so that you can inject this into like ASP.NET web applications. You can inject it as a payload into deserialization vulnerabilities without having to like inject something that knows how to fire up native shellcode. It actually looks like a fairly standard jittered .NET assembly with modules and all that sort of stuff, rather than going native. That's what this is all about. We're just sort of looking for another implementation that is less obvious in its behavior. Oh, you are? Excellent. Me too. We've been going at it for a while, and the whole plan of this was to build every single line of code, right? Every single line of code live on stream. Yeah, man, it's all open source. If you have a look at the YouTube channel or the Vimeo channel, let's go bang Vimeo, I think. Yeah, bang YouTube. All of the videos up until now have been archived there. There's 70 hours of content if you want to see it from scratch. I don't know whether there's a GitHub thing on here at all. There you go. There's the source as it currently stands with full commit histories and references to what we've done and the order we've done it in. Moobot's actually doing its job today. It's good. So yeah, there you go. It's all there. Exclusive address use. Gets or sets a bool value that specifies whether that allows only one client to use a port. Is that something that we need to specify in our server when we do our listener? That's something I hadn't considered. So when we do this .listener, is there a property here where I need to, exclusive. No. Maybe that's the, allow reuse of sockets rupture. That's sick, man. Thanks. Yeah, you're welcome, dude. So the first couple of streams kind of talk about the rationale and why we're doing what we're doing. So, hopefully that will make sense. But the primary goals were to show that software development is actually quite hard. Maintaining compatibility with existing solutions is also hard, and the whole point is to get an idea of what it's like to construct something within those constraints, while also learning a lot about the guts of Meterpreter. And I'm thinking so far we're doing pretty good. Prepare for a 70-hour slog of coding videos. Yeah, exactly. There's a lot there. There is a lot there. All right, let's quickly Google for some stuff. TCP client.net get peer address. There's got to be someone who's done this already. How do I get client IP using a TCP client? Sounds like it's just server on a load balance. No. TCP client remote endpoint address.string. The client's connecting via internet network. That's fine. That's all right. We can do that. Okay, so let's steal this. Client.remote endpoint. TCP client.client.remote endpoint. Oh, hang on. What was it? An IP endpoint. Okay, so we've got to do some lovely casting. Endpoint. Is that what it's supposed to be? Oops. Yeah, there we go. IP endpoint dot address, which is an IP address, which we can then go to string. Okay, so that's going to give us the peer. I assume that we can probably endpoint. Let's do this. Endpoint dot address dot to string. So we've got peer host, peer port 7Naro7. Thank you very much for the follow. It's good to have you on stream. Endpoint dot port. Excellent. Okay, it's all coming together. Flags. We can probably conjure those up ourselves, yeah? Var flags equals where did we actually use those? I don't think we've actually used them at all, have we? I think we pulled those flags apart inside the what was it? In the process, I think we did something with the flags, but we haven't done anything with the flags at this point. So I'm just going to pass in 0 for that. Channel class, we're just going to do the same sort of thing, some sane default. Look at that. We can actually give it the client as well. All right, let's do that. Return new TCP client channel. Channel manager. Peer. Ugh, can't type. Peer host. Peer port. Flags. Class. TCP. I'm just going to make this up, because I don't know what the channels are at the moment, so we'll come back to that and we'll pass in client. So class is an integer, is it? All right. Build succeeded. All right, let's take some bets. Who thinks this is going to work? And who thinks there's no way in hell this is going to work first go? Closing. So when we close this, we're going to have to go. You have faith. I'm glad somebody has faith. This.listener. How can we just kill it off? Accept. Stop. There you go. Stop. Winning. So that's when we're told to close from the other side, which is really the only time it's going to happen. So, shut up, multi. You're supposed to be on my side, man. Cut me deep. All right, let's do the reverse port forward thing again. All right, let's see what this does. It's good to see our wiring, for the most part, does its job. All right, so our host is 0.0.0.0.0, so it is actually specified. That's interesting. Let's create our channel, local port, bind address. Okay, so what do we got now? Bind address is the same as any. That's a win. Create the events. There you go. This is what I needed to do. Begin accept connection. And then once we've got a client connected, we need to go this dot begin. There you go. You need to restart it, right? So that we can listen for a connection again. Is that how that works? Let me just make sure that I've done the right thing. Do begin accept. Okay, accept one client asynchronously. So that's sitting on. Yeah, we don't need to actually do it that way, do we? I mean, we've got processing the client connection happening async. So I'm thinking that we don't do that. We can probably completely do away with this because we're not doing this across threads. And it's not like we're going to be sitting here dealing with enormous amounts of servers that are connecting, or clients that are connecting through this port forward, right? Yeah, let's do that. So we call begin. And then once we've accepted, we can straight away begin again. There we go. And then if the client connection actually came through, then we can go and process it. Okay, let's try that again. All right, so we are creating our listener. We start the listener. Now, what happens over here, I would assume, is there anything that's whinged? I would expect, oh, I've got the firewall disabled. netstat-antp, no, ant, pipe, find, stir, listen. All right, so we should be listening on 99999. There we go. Okay, so we've got our listener. Security for the win. I know, my dev machines have all of that stuff turned off. What a surprise. Okay, so let's see if we can get an NC working. All right, let's just go NC. So we're going to NC to whatever what's the IP address for that thing? 130. I'm going to connect to that on 9999, and if it all works, like, it should basically come through here, right? That's the point. Let's see what happens when we get a connection, if we get one. Okay, so there we go. We've got a connection. We kick off the async again. Do we have a client? Yes, we do. Wrap it up. Flags, client, get stream, read buffer, begin read. And what happened? Ah, that didn't connect to this. So that would be the first mistake. Stepping over property, yeah, that's fine. So the question here is, Ah, look at that. Standard API net TCP server is the type. So it hasn't picked up on the fact that we've tried to create a client channel here. Ah, that would actually make sense because we haven't dispatched that information, have we? Far out. Share this with the guys at work and they already know about you and also think this is really, dude, thank you so much. That's lovely to hear. That makes me very happy. And I hope that you guys get some value out of watching this stuff. And please jump on the Discord and hit me up on the Twitters and whatnot. Like I said, the goal of this is to try and get as much out of here and as much out of the Metasploit source and share the knowledge on how it all works and how you guys can extend it. And you know, with more knowledge of how this stuff works, you can go off and do your own thing. It's just I like this as a means to, I don't know, get people involved and demystify things a bit. So yeah, thanks for that. Really appreciate your comments. Now let's go and actually create the channel, because this is basically what I needed to do. Where's the core channel open message? Process. Oh no, I don't need to do it that way. I need to do it the other way. Righto. That means we go back here and we come into the server. So once we've got all this stuff, we have to do this. This is what we have to do. I think it actually all worked as expected, but because we didn't tell Metasploit about this, it was unable to receive the information. Which Discord server? This one. Alright, so we're going to create a new channel with... Where is that create packet again? Create response. You are welcome, Benzies. Please jump in. I thought you were there already, mate. Clearly not. Local. Okay, so one thing that's interesting here is that nettlv pack local address info. So when we create the instance of the server channel, do we need to add something else to the response? Server channel. We do. We probably should. So what is it adding? What does this do? nettlv. Let's look for the body of that in a separate window and see if we can emulate it. Here we go. So what is it adding? It's getting the socket name, sock address, adding localhost and local port. Okay, well we kind of know that, don't we? But clearly that's what it's doing. It's just adding localhost and local port. Okay. Yeah, we'll go channel equals. We'll go and create a new one. We're going to return that to the channel manager because the channel manager will add the channel identifier and whatnot. But what we should do is let's go response dot add tlv type dot standard API standard API localhost. Yep. Add. Now what we'll do is we'll add this to the actual channel type itself. Channel dot localhost. We'll expose that as a property. We actually don't need to do the port, but I will in the same way. Alright, so channel public int local port. Let's go and return start bind address. No, not bind address. Local port. And then with the local host, bind address dot. Let's do that. I think that should be okay. Okay, so that means like if localhost isn't specified and we end up binding to global, it'll return that global string instead of just assuming that what we've given it or what we get out of our original TLV packet actually has a valid value. We can delegate the responsibility to the server channel to figure out what the localhost would be if it's not specified and return that string to us that way. Okay, so that technically does the same thing as what we're doing here. And then once that's done and we actually get a client coming in, that is a different thing altogether. So let's go create, hang on, packet, create. Packet doc, oh, that's right, I changed it to Met API. Okay, so this is now what we need to shove in. Okay, we need to do this. I just learned today that Linux will happily connect to blah, but Windows will say screw you and pick it. Yes, that's right. IPv6 in Windows is a mess. Not gonna lie. Alright, so that creates there. Okay, so when the client has been created, we then need to go packet equals new packet. The method that we're giving it is TCP channel open. Okay, so now we need to go packet dot. We need to add the channel ID. Packet dot add TLD type dot channel ID client channel dot channel ID. We need the parent ID, parent channel ID, channel. Is that what it's called? Channel parent ID. Channel parent ID will be this dot channel ID because we are inside the server. Then we need to add the local host, local port, peer host, peer port. Okay, so standard API local host. So that is what we're currently listening on, which is this dot localhost. Right? And then we've got standard API local port. Crikey. That's going to be this dot local port. Then with those two done, we can change this to peer host and peer port. And from here we should be able to do client channel dot, and we'll provide the abstraction to do the same thing here. Okay. We'll go peer host client channel dot peer port. So we can abstract that inside our client channel class. So here we've actually got a bit of code that does it when we create things here. Let's do the same thing. Okay. Public string peer host get public int peer port get. All right. Oops. So the port we're just going to go return IP endpoint of the actual client, which is this.tcp client.remote endpoint.port. And then we can do the same thing here, but address.string. Okay. Beautiful. Does that make sense? That should work, hey? Now, let's set a breakpoint again on when this magic happens so that we can see it all. Now before, here we go. We created the packet. Channel manager, dispatch the packet. We got to tell Metasploit about it. No point in creating a packet and then not sending it. Peer host, peer local, parent channel, boom. Add. That's pretty much all we have to do. All right, any questions? We're pretty close. Once we've got this little bit of thing working, I'm going to stop because we're already 20 minutes over. And I really need to do a better job making sure I get this done and go to bed early so that I can do my job the next day. But I'm stoked. We've had a good turnout. We've had consistently over 30 people for most of this stream, which is really nice. Very much appreciate everybody's support. Okay, what happens here? Oh, we don't need that. We can let that go because we know that we're going to have a server channel there. All right, so I hate you guys. All right, let's see what happens. Create the things and off we go. Ooh, look at this. Yeah, boys and girls. Check it out. That's pretty cool, huh? Yeah, so this Rex Post Meterpreter extension is standing up our NetSocket subsystem TCP client channel. That actually is the class name inside the Ruby namespace. You don't want to dive into this. It's painful. All right, so if I exit out of this, I don't know what's going to happen. Oh, look at that. It worked. It just worked. Oh, I'm stoked. I wonder if that actually freed up the channel on this side. Let me see. Channel manager. Active channels. Yeah, it did. It just worked. Now this one's interesting here, yeah? Okay, here we go. Core channel closed. So I need to handle this case here. Because we need to inform the client on this side. So this is the last thing we're going to do, right? We're just going to make sure that the core channel close message that comes in when we terminate the client on the other side actually gets handled properly. So channel manager, channel interact, channel close. Are we still running? Yes, we are. All right, set up the listener. Listen. Fail. What happens? So we get the close message. We pull that out, and in here, what do? We close the TCP client. So what is it that we need to know at this point? We need to signal that this thing needs to terminate, which I would have assumed would have happened here. Why did this not terminate? Did something go wrong? TCP client exception. Okay, so are we closing? So that's exactly what I would expect. But what I want to make sure of is that the client that is associated with this object is terminated. Active is true, connected is false. Inter-network blocking true, connected, handle is bound, protocol. There you go, the object has been disposed. So why has this not been informed? Any ideas? Because as far as we are concerned, at this point, we don't have a connection, do we? Well, clearly we do if NetStat's, if NC's still running. We've got the listener. (443, 443, 443). Local address needs to be that. And I can't see any instances of it, can you? Nine, 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 nine. Okay, so if there's literally no client socket left that's talking on this port, I don't see why this is still open. I'm a little confused by that. I would have expected when the client socket is terminated that NC bails. Like so when I go local, NC localhost 8888. So when this bails, oh look, I was wrong. It is an NC thing. So it does work. It works exactly as we expect. Hooray! Okay. We're done. I only went 25 minutes over. Is that good? You proud of me? Alright, let's flick modes. For those people who haven't been paying attention, here's Nelson down here having a laugh at me. I love that. I think that's so good. Alright, where are we going? Back to... There we go. So there's the end of part 35. We're 72-ish hours into the entire process. Thanks, Rupture Reality. Appreciate it. It was really nice to have you come on and send my regards to the crew behind the scenes. And like I said, jump on Discord and whatnot if you feel like it and fire over the questions and whatnot. I hope you guys got something out of it. I'm glad we managed to solve the problem with the process channels. And now that we have TCP server channels and whatnot, we're making good progress, huh? 72 hours, 35 parts, 14 months. Yeah, so April, I posted in Discord earlier, didn't I? It's like mid-April. So we're mid-May, be 13 and a half months-ish in total, 75 hours. And we had a big break from like the end of the year, mid-December up to, what was it, late March-ish, I think. There's a good 3 months off these streams and we were just doing Pico CTF for a while. So yeah, spend 2 hours on an exploit, you just go and fix it. Spend 2 hours on Meterpreter and it's forever. Amen. All right, well look, I will love you and leave you all. Thanks very much for joining in. As always, it's a pleasure to have you all on and I appreciate your support. And I will chat to you on the Discords, and we'll do another one next week. And yeah, Alvaro, so good to have you as well, man. Thanks for jumping on. All you regulars that keep things sane and make me happy, thank you for being here. Love you all very much, and until next time, be good to each other.